Right now, as you sit in your home, roughly 2/3 of every dollar you spend on energy goes toward one thing: heating and cooling the air around you. Not your lights, not your appliances, not your electronics, just temperature. And 6 feet beneath your foundation, right now, today, regardless of whether it is blazing summer or brutal winter on the surface, the soil is sitting at a constant 50 to 55 degrees Fahrenheit. It has been that temperature for thousands of years. It will be that temperature long after your furnace rusts out and your air conditioner dies. The ancient Persians knew this. They used this exact physics to store ice through summers that reached 120 degrees. The Romans cooled their villas the same way. And right now, modern Germans are building these systems legally with off-the-shelf materials for $300 or less. The core of it is almost absurdly simple. A length of plastic pipe buried in a trench and a weekend of digging can slash your heating and cooling costs to nearly zero. Not reduce them, not trim them, functionally eliminate them. Here is what we are talking about. Earth tubes, sometimes called earth-air heat exchangers. Buried pipes, typically 4 to 6 inch diameter PVC, running 6 or more feet underground, where the soil maintains that near-constant 50 to 55 degrees Fahrenheit temperature year-round. The concept is so straightforward it almost sounds like it cannot work. Hot summer air enters one end of the pipe at 100 degrees Fahrenheit. It travels through 60 to 120 feet of buried pipe. The surrounding earth absorbs the heat. The air exits the other end at around 62 degrees Fahrenheit. That is a nearly 40-degree temperature drop with no compressor, no refrigerant, no electricity, and no moving parts. In winter, the process simply reverses. Frigid outside air, at say 20 degrees, enters the pipe and gets pre-warmed by the ground to around 50 degrees before it ever reaches your home. Your furnace, if you even still need one, barely has to work. The completely passive version requires zero electricity. You seal the house, open one high window, and the thermosyphon effect does the rest. Hot air rises and vents out the top, pulling cooled air in from the buried pipe below. The ground at 2 to 4 meters depth acts as a free thermal battery that never runs out and never needs recharging. It is not a gadget. It is geology. Now let us talk about why the number $20 keeps coming up. The core material is non-perforated plastic drain pipe, the same kind used for drainage projects, available for under $1 per foot at any hardware store in America. A short single-run system for a small home or even a single room can be built with salvaged or discount pipe for as little as $20 in materials. The real cost is labor, specifically digging the trench. But here is the thing. If you are already excavating for a foundation, already trenching for landscaping, already digging for a septic system, the marginal cost of dropping a pipe into that trench is essentially nothing. You are already moving the dirt. Compare that to what the market wants to sell you. A mini-split air conditioning unit runs $3,000 to $8,000. A professionally installed geothermal heat pump system costs $15,000 to $30,000. And even if you add a small inline fan drawing 50 to 80 watts to actively push air through the pipe, that is the only electrical component. And even that is optional in a fully passive setup. The economics are not slightly better. They are a different category entirely. But does it actually work at scale, or is this just backyard tinkering? The peer-reviewed science is unambiguous. Studies published in major journals show that earth-air heat exchangers deliver cooling coefficients of performance around 5.9 to 6.2. That means for every single unit of energy you put in, you get nearly 6 units of cooling out. Compare that to a standard air conditioning unit, which achieves a coefficient of performance of 2.5 to 3.5. The earth tube is outperforming your AC unit by nearly double on raw efficiency. Research published in scientific reports found that Earth air heat exchanger systems reduce total cooling energy demand by 16 to 66%, depending on climate zone and system design. Multiple studies have documented temperature drops of 10 to 12 degrees Celsius, that is 18 to 22 degrees Fahrenheit, through the buried pipe alone. That temperature drop is enough to eliminate air conditioning entirely in moderate climates. The Environmental Protection Agency estimates that ground source systems save 50 to 60% on heating bills alone, and that is their conservative number for professionally installed systems, not the do-it-yourself version that costs a fraction. One particularly well-documented stone earth tube build showed 100-degree air entering the pipe, dropping to 75 degrees at the 60-foot mark, and exiting at 62 degrees at the end of the run. These are not theoretical projections. These are thermometers in pipes producing real numbers. So how do you actually build one? The design rules that matter are specific and non-negotiable. Bury the pipes at least 6 feet deep. 4 meters is ideal for maximum temperature stability, well below the frost line where seasonal temperature swings cannot reach. Run 60 to 120 feet of straight pipe. Longer means more cooling capacity, more surface area for heat exchange with the surrounding earth. Here is the critical detail most people miss. Maintain a 2% downhill grade toward a drainage sump because condensation will form inside the pipe. In humid climates, this can mean gallons of water per day collecting inside your tube. If that water pools and sits, you have a problem. Use smooth wall PVC or SDR35 sewer pipe only. Never, under any circumstances, use corrugated or ribbed pipe. The ridges trap moisture in every valley, creating standing water that breeds mold and degrades your air quality. This is the single most common mistake in do-it-yourself earth tube builds, and it is completely avoidable. Screen and filter the outdoor air intake to keep insects and debris out of the system, and position that intake at least 15 meters from the house to ensure you are drawing fresh air, not recirculating exhaust or dryer vent output. Bring the cooled air into the lowest point of your living space and vent hot air from the highest point to work with natural convection rather than against it. Bed the pipe in compacted sand, not loose fill, for maximum thermal contact with the surrounding earth. Air pockets around the pipe act as insulation, which is exactly what you do not want. And mark your pipe locations clearly so that 5 years from now, when you are planting a tree or running a new utility line, you do not accidentally dig through your own cooling system. The real-world results from families running these systems are where this moves from interesting to compelling. Homeowners using earth tubes report eliminating air conditioning entirely in temperate climates, not reducing their usage, eliminating it. European performance data from 847 monitored installations shows homes maintaining 72 to 75 degree interiors without any mechanical air conditioning, even when outside temperatures reach 95 degrees. The Passive House Institute in Germany, which maintains some of the most rigorous building performance standards in the world, documents an average cooling capacity of 3.2 kilowatts from earth tube systems with an 89% reduction in mechanical cooling demand. The average payback period across these installations is 12 years, after which your cooling is essentially free for the remaining life of the system. Combined with even modest solar panel installations, families across Europe and increasingly in the United States have reached true net zero energy bills. Not low bills. Zero. And at a hospital in Vienna, an earth tube system has been providing 450 kilowatts of cooling to critical care units continuously since 1994. That is over 30 years of uninterrupted operation in a medical facility where failure is not an option, with cleaning required only every 5 to 7 years. If a hospital trusts this technology to cool its intensive care ward for 3 decades, the question of whether it works is settled. Now here is where intellectual honesty matters, because there are real risks and real limitations, and anyone who tells you otherwise is selling something. Mold is the most commonly cited concern, and it is legitimate, but it is also entirely preventable. If you skip the drainage slope or use ribbed pipe, standing water will collect and mold will grow. A proper 2% slope with smooth wall pipe and a drainage sump solves this completely. It is a design choice, not an inherent flaw. Radon is a more serious consideration in certain geographies. In radon-prone areas, poorly sealed pipe joints can allow radon gas to infiltrate your air supply. The solution is tight, sealed joints and quarterly air testing until you understand your specific site's radon profile. Activated charcoal filtration reduces radon concentrations to background levels at under $60 per year in filter replacements. Humidity is another honest limitation. Earth-cooled air can arrive humid, particularly in already muggy climates. You may still need a small dehumidifier to reach full comfort, though your energy expenditure will still be a fraction of running a conventional AC system. In extreme heat above 115 degrees or in extreme cold, earth tubes alone will not deliver full comfort. What they will do is precondition your air, dramatically cutting the load on whatever backup system you choose to use. Your backup system runs less, works less hard, and lasts longer. Continuous 24-hour operation during extreme heat waves can gradually degrade performance as the immediate soil temperature rises around the pipe. Running the system primarily during morning and evening hours and letting it rest during peak afternoon heat allows the thermal battery to recharge naturally overnight. And you need a yard. You need the physical ability to dig a trench. This is not feasible for apartments, condominiums, or homes with zero lot lines where your property boundary is your exterior wall. Here is where we land. For $20 in pipe and a weekend of labor, you are tapping into the same geothermal principle that costs $25,000 when a licensed contractor installs it with specialized equipment, proprietary components, and a markup that reflects their overhead, not the value of the physics. The earth beneath your house is already the right temperature. It has been the right temperature since before your house was built. You do not need to create cooling. You do not need to manufacture heating. You just need to connect your living space to the thermal mass that is already there, 6 feet below your lawn. The physics that makes this work survived because physics does not care about marketing budgets or industry lobbying or the quarterly earnings reports of HVAC manufacturers. It simply works. It worked for the Persians 2,400 years ago, storing ice through desert summers that would melt anything on the surface. It works right now across Europe, in thousands of monitored installations producing documented results. And if you build it correctly, with the right pipe, the right slope, the right depth, and the right filtration, it will work quietly and efficiently beneath your home for 50 years or more. The only question left is whether you are willing to spend a weekend digging to find out.